Okay, this is the 7B retake review, so dealing with the proofs part of quadrilaterals. And as I always say that proofs, the really only way to get better at them is to do them. No two proofs are exactly the same, so the whole process is always going to be a little bit different. On these ones, we have choices, just like you do on your standards quizzes. So hopefully that is helping you. As we look here, okay, we are always going to start with our given statement, which we are being told that we have a parallelogram with diagonals EJ and HF. And then we're being told that FHG, so this angle right here, is congruent to EFH, which is this angle right here. Now, how do we know that? If we look at our choices down below and we look at what type of angles we have, right? These are alternate interior angles. Remember, the definition of a parallelogram is the opposite sides are parallel. So I have parallel lines with opposite interior angles. So that would tell us that this is that alternate interior angles are congruent, which is choice B down there, I guess. I should probably label those B right there. Given wasn't one of our choices. Oh, it was G. Okay. All right. So then it says that EF is equal to GH. So EF, this side right here, is equal to this side right here, GH. And that's our choice E, right? We know this about parallelograms. The opposite sides in a parallelogram are congruent. And then we have angle EKF is congruent to angle HKG. So EKF congruent to angle HKG. And this is because we know that all vertical angles are congruent. This is something we've known for a long time. So then if I look at my picture, I have two angles and a side. The side is outside of the two angles, so that tells us that we are using angle side to prove that those triangles are congruent. Okay, let's look at our next proof here. All right, so we are again told that we have a parallelogram, and we are told that AD is perpendicular to DC. So AD right here, this angle is a right angle. Okay, so that's a given statement here for us. I guess I didn't realize if this proof is off the screen here. Let's see. It is. Let's make it a little bit smaller, if I can do that. So we can see it all in the same screen. Let's see. I'm going to go like this now. Try to fit that in. It's not going to quite work. That's okay. I can just rewrite some things. Okay. Alrighty. Sorry, you got to see some of my little fixing of some technology. So this one was a given, which was choice J. Okay, and then it says angle ADC is a right angle. So that's this angle that was down here. That's the definition of a perpendicular line here. So really what we're using is this choice H, right? That perpendicular lines form right angles. I'm just going to do this. Okay. I'll go like that. Make it more sense. Okay. Choice H there. Okay. And then the measure of angle ADC is equal to 90 degrees. This feels a little bit repetitive here, right? But this is choice C. This is the right angles equal 90 degrees. Okay. And then we are told that ABCD is a parallelogram, which we were given that at the beginning, which means that this is parallel to this, and this is parallel to this by definition. So then it says that measure of angle ABC equals 90 degrees. Okay. The reason we actually know this is because opposite angles in a parallelogram are congruent. So that's choice D right here. Right? We always know that that's true about parallelograms. Opposite angles in a parallelogram are congruent. A lot of abbreviating being done here. And then it says the line ABC is parallel to line DC. And so this is the definition of a parallelogram, which is choice K. That the opposite sides are parallel. Okay, now step 12 here says that angle ADC plus angle DAB equals 180. We know this is true because consecutive angles in a parallelogram are supplementary. And so, but also, we know this is true because since I have parallel lines, so ADC and DAB right here, these top two lines are parallel, then we know that and then if we consider this to be a transversal right here, we know that same side interior angles must add up to 180 degrees. So this is actually choice J. I was writing J for given earlier when really it's B. I was missing that. Sorry. So this one says that we have same side interior angles add up to 180. And so then we know what angle ADC is. We know that way back up here. So we're just substituting it in place right here. So right now we're going to use the substitution property of equality. Okay, and then if we just solve this equation by subtracting 90, then we get to our next equation right here. So this is choice A, which is the subtraction property of equality. And then we also know right here, let's see, that BCD equals 90. BCD equals 90 degrees. Oh, that's because we just learned that this one equals 90. So now if we're saying that BCD equals 90, we're saying that we have opposite angles in a parallelogram that are the same. So that's, again, we're using choice D here. And it's okay to repeat options. Okay, 16 says that angle DAB, angle ABC, angle BCD, angle ADC are right angles. And we've kind of established this throughout this whole time frame by saying that they're all equal to 90. So really, what I think what we'll be using here is the definition of a right angle, because we said that they were all equal to 90 degrees. And then finally, ABCD is a rectangle, and this is what it means. This is how a rectangle is defined, is that all four sides are 90-degree angles. So this is definition of a rectangle. Definitely a more elaborate proof than the first one. Hopefully this made some sense to you. If you still have questions, please reach out to your teacher. We are here to help and available for you. Good luck and keep up the good work.